Hi everybody. This is lecture 17 for our statics class, and lecture 17 is going to be the last lecture before I review for the midterm exam. So the content of this lecture is section 4.3, which we also talked about in lecture 16. So I have assigned you one more problem so that the total homework set for chapter 4 is only 5 problems, but as we've seen so far, they're very lengthy. So the problem that I've assigned today is 132, and I want to give you some direction on solving it, perhaps a little bit of new information, but show you how to get through the grind. So first of all, you'll notice that here on your Moodle page we have notes for statics lecture 17, and that's what I'm going to be speaking from today. So the first thing is lecture or problem number 4.132 is a rod that extends from point B to point A, and it's kind of slanted. If you think about it, from B to A, it's slanted out of the page 150 millimeters. It's held in place by a cable CG, which is slanted backward and is applied from the middle of the rod. So we have a frictionless support here at B, and we have a ball and socket support at A. Then we have the tension. Now, in the problem, it tells you that the rod is a uniform rod of a mass of 10 kilograms. What that means is that the weight of the rod acts from the center of the rod. So the first thing we can do is to calculate the weight, which is 10 times 9.81, or 98.1 newtons. And the next question is, where does it act? Well, the answer is, if it acts from the center of the rod, if we can find the measurements or the dimensions of the entire rod A to B, that the center of the rod will be halfway through in each direction. In other words, when we find out, for example, that this dimension from A to B is 300 plus 300 or 600 millimeters, we know that the weight will act from 300 millimeters in the X direction. The tension acts from the same spot. So what I've done today is I've set up how to find those vectors so that when you go to solve this problem, you'll have an easier time, or at least you'll know where to go. So the rod from A to B goes 600 millimeters in the X direction to the left. It goes 400 millimeters in the Y direction up, and it goes 150 millimeters in the K direction out of the page. So halfway is exactly half of each of those measurements. 600 divided by 2 is 300, 400 divided by 2 is 200, 150 divided by 2 is 75. And we know that the weight, because it acts in the purely vertical direction, is, and I have 981, it should read 98.1 newtons. So since R sub B is frictionless, you can look at that page in your textbook that shows you what type of reactions are borne by each type of support. A frictionless pin acts perpendicular to the surface of contact, so that's going to be purely X. The R sub A, the ball and socket, has X, Y, and Z components. And the cable, I wanted to point something out here, and I put this as a negative to show you, from G to C. Let's go back to the picture and look. From G to C, we know that G acts in the center of this rod, and we know the location of C. But the deal is that we know that the entire rod A to B is at 75 millimeters, or is at 150 millimeters. So that means that G, point G in the Z direction, is half of that, or 75 millimeters out of the page. So that means that the entire distance from G to C is 75 plus 150, or 225 millimeters. And I put that here with a cross out to make a point, because I think it would be very easy to mistakenly call that 150 millimeters. So we have the cable from G to C. We want to find the tension from G to C, but we need to find lambda, which we've done on previous problems. So up to here, all of these hints will get you ready to set up the equations. Now, the other part of the deal is that the summation forces x, y, and z will all have to equal 0, and so will the moments in x, y, and z direction about any points. Now, one of the reasons I chose this problem is because it pretty much forces you to do the moments, and if you take the moments about point A, what you'll see is that none of these reactions will come into the equation because there's no moment arm. So all you'll have is the tension and the weight and the reaction at B. So you have 3 equations and you have 3 unknowns with the moments. So that means that here the mathematical simplification is, first of all, to take the moments about point A, and then second of all, to just do the moment equations and see if you get enough information to solve for those 3, which you will. But you won't get anything out of the x, y, and z equations that will allow you to make the solution. All right, so that's it for this lecture. That's it for Chapter 4. The next lecture I'll do will be 18, which will be a review for the midterm exam. And please, as always, if you have any questions, get a hold of me. Either email me or call me or come find me on campus, or we'll talk to you in class. Thanks.